Hello and welcome. In this video, we're going to explore how to make some intersections between curves, curves and surfaces, surfaces and surfaces, and so on. Every possible intersection that you can make between two geometries. So in this case, we're going to deal with a new namespace called Rhino.geometry.intersect, which is actually a child namespace under the Rhino.geometry. And under the Rhino.geometry.intersect namespace, you can find some intersection classes and enums. So an arc intersection enum, a circle intersection enum, a curve intersections class, an intersection class, and intersection event class. And those three actually will be the main classes that we're going to deal with in order to get real events. So the other classes will be more of a checking of if there is an intersection or no. So if we go to the arc intersection enum, it returns a 0 where there are no intersections between two arcs, 1 if there is 1 point, and 2 if there are 2, and 3 if there are 3, or there is an overlap. And the circle intersection is also an enum, and it's sort of a result or the output of some of the components or some of the methods of the intersection class. So let's check the intersection class out, and here we have a constructor which initializes a new instance of the intersection class. There is one property for the mesh intersections, and here are 52 methods to get every possible intersection between any two geometries. There is the arc intersection, which gives us an output that is an arc intersection enum. But we can still, using this method, get the point 3D intersection, the first point and the second point's intersection. And actually, I don't have these methods, the arc, the circle intersection, maybe because I'm using Rhino 6, but I can't find it in the C#. I can't find these methods under the C# script here. So if I add a C# script and type Rhino.geometry.intersect.intersection, here I can find the arc intersection method, maybe because this is, as I said, Rhino 6. Maybe you'll find it if you're using Rhino 7. But anyway, let's try some of the available intersections in Rhino 6, which are the brep plane, brep surface, a curve brep, a curve and a line, two curves, a curve and itself, and so on, a line and a box. We'll try some of these. And actually, I think maybe we can find a line and a circle. And I've prepared some of the intersections here between some geometries. So let's start with this line circle and let's check it here. So a line circle method will give us a result that is a line circle intersection enum. In order to do that, let's try this. We'll type here the data type, which is Rhino.geometry.intersection.line line circle, or we can just type variable called intersection. And this will be equal to, again, Rhino.geometry.intersection.line circle. And let's check what we're having here. So it needs a line and a circle, of course, and it will output a double called T1, and it will output 1 point. Let's call it point A, and output another point. That's of course in case the line intersects with a circle in 2 points, so In our case, yes, and this will be called point B. And here we can just output T, and T is a double, which is a parameter, and we'll leave this empty, and we're going to declare a point 3D variable called point A to store this point inside, and another point 3D variable called point B, and again we will leave this empty. So again, we've mentioned before in previous videos that in order to get a point in some methods, we'll have an out keyword. Out keywords mean that this method can give us maybe an array of points as we've seen before, an array of curves. It can output the points of intersection, and that's what exactly we need. So here we'll say A equals point A and B will be equal to point B. And if we run this and add the B, we have a problem that the line and the curve, the circle, are not added to the input. So here is the line and here is the circle. We have to rename it to line, and this will have a type line, and this is our circle, and it will have a circle type. And it doesn't work because line circle takes 5 arguments, 1, 2, 3, 4, and 5. So what is our problem here? Okay, let's try adding this again. So a line, a circle, out T, and out point A. Okay, out. Oh, okay. We have a missing parameter here, which is out T2 and out point B. So now we need to add another double here, which is called double T2, and if we run this, should work. Yes, it works here, and it gives us the 2 points where the line intersects with the circle. And of course, T is a parameter, so we can get the point by typing, instead of outing the point, we can just type line.point@, and in this case we'll pass T. And here we can do the same by typing line.point@, and in this case we'll type T2, and this should give us exactly the same 2 points. So we either get the point by getting the point at the line with the parameter that we get from this method, or we can just output our point directly. And here is our first point, and here is our second point, and that's an intersection. We can get the intersections of a curve with itself. To check this, let's see the curve self method. And in the curve self methods returns a curve intersections in them. And here we can type the method curve self, and we add only the curve and a tolerance, and it doesn't actually give us any outs, so we will not get the points. Let's see how to deal with this. Let's at first make our component here. Let's call the input curve and make sure that it has a curve type. So we have this curve here, and let's try and do this. We'll type rhino.geometry.intersect.intersection.curve self, and here we'll add our curve and the tolerance, which is 0.001. This method returns a curve intersections class. So let's type var intersection, or if we can still type rhino.geometry.intersect.intersection.curve intersection. But anyway, if we run this code, this should return no errors at all. But still, we don't have any output. So what we can do in order to get the actual point of this intersection, if we return to the curve self intersection, it returns a collection of intersection events. So what is an intersection event? We can find the intersection event under the rhino.geometry.intersect. And if we check the intersection event class, we can get points, which are point A, point B. We can get the parameters and then get a point at a certain parameter of the curve and so on. So if a curve solve returns an intersection event, we can just type here intersection, and then we'll choose the first event that happens and get point A. And let's type here point 3D point A equals intersection 0, and if we run this, then there are no problems in our code. And here we can type another point, which is point B, and get the second point of intersection here. If we run this code and add a B, and let's see what A is equal to, here it will be equal to point A and B will be equal to point B. And let's run this, and we have the first point. Actually, point B is not the second intersection event. So here, this is our first intersection. If you want to get the second intersection, we type here 1, and it will give us the second intersection event. And if we type 2, it will give us the third intersection event. And if we type that B is equal to intersection, we can check how many intersection events happened. And if we stop here, there are 3 intersection events. So the B returns 3 rhino.geometry.intersection event here. And this is an array. So if we want to get the point, we have to use here an index of this array in order to get the first intersection event, which is 0, the second, which is 1, and the third, which is 2. And here we can get the point at, or we can get the parameter actually. If we type dot parameter A here, we can say that A is equal to curve dot point at, and here we type double point A, and here we type at point A, and here we can again get this point. So very easy, but it's a bit of harder than what we saw in the geometry creation, which was maybe straightforward than this, because here in this case we go to the intersection class and use a method, and then the intersection class returns another class which is called intersection events, and then we have to deal with the intersection events method in order to get what we want. But anyway, it's just an easy logic, I think, and it depends on how you read the returns of this method, of every method. So let's try another method and see what it gives us, and see how to read it again in a logical way. Let's try with a line and a curve. And to make an intersection between a line and a curve, we'll head again to the intersection and check the curved line. The curved line, again, returns a collection of intersection events. So it will work like the curve self method, and it's a static method, and it returns the curve intersections class or enum. And let's try this. We need a curve, a line, and two tolerances. So let's try this out using a C# script and type here. So variable intersections will be equal to rhino.geometry.intersect.intersection.curve surface. And here we need a curve, a surface, and two tolerances. And now there will be an error because we didn't type our curve and nor our surface. And here we'll make sure this is a curve type and this is a surface type. And if we run this again, let's see what, we need to name this surface, and this should be working now. Yes, but it returns nothing. In our Rhino interface, there are no points. Let's get the points of this intersection, and to do so, we'll again say that point 3D, point A, will be equal to intersection. But before that, let's check how many intersections happened. In order to do this, we'll say that output A equals intersection, and let's check how many events happened here. There are two locally defined values, which are two intersection events. So we need 2 points. So intersection 0.point A, and I think we need to add these brackets, but let's check. And point B will be equal to the second event, and B will be equal to point A, and C will be equal to point B. And let's check if this runs. No, we need to remove the brackets. Yeah. And here we get our 2 points that result from the intersection of a curve and a surface. I'll stop this video here, and let's continue in the next video with some other intersections. Thank you for watching.